Welcome to this explainer on shape memory materials. Okay, picture this. You take a completely crushed, mangled piece of metal, drop it into a bowl of hot water, and bam, it instantly snaps perfectly back into its original shape. Or imagine a piece of plastic that just folds itself up like origami, totally on its own. Honestly, it looks like literal magic or some crazy sleight of hand. But today, we're going to reveal the science behind the illusion. We are diving deep into materials that seem to have a mind of their own, but are actually grounded in some of the absolutely most fascinating engineering happening in the world right now. So to start us off, we really have to ask a fundamental question. When did shape memory materials actually first emerge? Now, you'd probably think this is some brand new, highly classified breakthrough from a high-tech lab, right? Actually, scratch that. To trace their true origins, the source material tells us we have to look way, way back to the dawn of biopolymers. We're talking billions of years ago. Nature was the very first architect of shape memory. These natural biopolymers have literally been shifting and adopting in biological systems long before humans ever even conceptualized the idea. We're really just taking cues from a very ancient biological playbook. All right, here is our roadmap for today. First, we'll cover materials that remember, then alloys, polymers, and hybrids. Next up is DIY and everyday magic, followed by saving lives with smart tech. And finally, we'll look at the future with 4D printing. Okay, let's jump right into part one, materials that remember, and the actual science of shape-shifting. The Source Index breaks this field down into two main heavyweights. First up, we have shape memory alloys, or SMAs. These are your metal-based materials. A really famous example mentioned in the sources is superelastic nitinol. It's this incredible blend of nickel and titanium that is just amazingly resilient. On the flip side, the other major category is shape memory polymers, or SMPs. This covers a massive range of nonmetals, things like thermoplastic and thermoset plastics, resins, and even these crazy water-swelling hydrogels. So, while the metal alloys are incredibly strong and durable, the polymers are highly versatile and honestly often much easier for engineers to program and manipulate. Moving right along to section 2, alloys, polymers, and hybrids. Basically, what are the secret triggers? Because, these materials don't just morph randomly for no reason. They require specific programming conditions and environmental triggers to activate what experts call the shape memory effect. And the brilliant part? Scientists can completely tailor these triggers. The most common one is thermoresponsive, meaning the material shifts its shape when exposed to specific heating or cooling, like, say, body temperature versus room temperature. But it doesn't stop there. There are chemoresponsive materials that react specifically to moisture or water, and there are even photoresponsive materials that physically shift when they're hit by specific wavelengths of light, like UV rays. This tailored programming means we can design a material to react exactly when and exactly where we want it to. Which brings us to section 3, DIY and everyday magic, taking this from concept to consumer. Because the coolest part is that the shape memory effect isn't just some theoretical lab science anymore. It's literally being used for everyday consumer items and DIY projects right now. The sources list a super fascinating array of accessible applications that you could engage with today. We all have that one fraying phone charger, right? Well, there are DIY shape memory polymer sleeves designed to perfectly wrap and protect your power cables once you heat them up. The index also points out DIY shape memory screws, shape memory foams, and even these awesome little retainers for the temple tips of your goggles or glasses that mold themselves to perfectly grip your head. And this brilliantly illustrates how these materials provide what the sources call comfort fitting. Just think about the things we wear every single day. The data points to shape memory shoes that learn and hold the exact contour of your unique foot, or even invisible mask holders designed for a vastly improved fit. Basically, instead of using rigid structures that we have to painfully force our bodies to adapt to, these materials effortlessly adapt to us. And the technology even extends into some really playful, surprising stuff. The source index specifically mentions things like 4D latte art and spinning 4D latte art. Just imagine putting a flat piece of edible shape memory polymer on top of a hot cup of coffee. As the heat hits it, that thermal trigger causes it to fold up into a 3D shape, maybe even spinning, right there in your mug. It's a fun little example for sure, but it perfectly highlights just how incredibly versatile and safe some of these polymers can be. Let's get a bit more serious in section 4, saving lives with smart tech. We're talking biomedical applications. Because this tech goes way beyond phone chargers and coffee art. Biomedical applications are where shape memory materials truly shine. Since these elastic polymers and alloys can be programmed to respond to specific temperatures, they can actually be body temperature programmable. Let's walk through the steps for a surgical wound closure. Step 1. A surgeon inserts a shape memory surgical staple, or maybe you apply a specialized Band-Aid. Step 2. Your own body heat acts as the thermoresponsive trigger. Step 3. The material automatically constricts and self-tightens to the exact right pressure. No manual tying, no tricky tightening required. The material does all the work purely based on the heat of your body. Mind-blowing, right? The index also highlights some highly advanced internal medical projects. We're talking about shape memory plugs that can be inserted minimally invasively into a really tight space, only to expand and completely seal off an area once they warm up to body temperature. Or, get this, dynamically adapting artificial blood vessels that can actually mimic the natural expansion and contraction of our own circulatory system. The implications here for less invasive surgeries and dramatically better patient outcomes are just immense. Finally, we hit Section 5, the future. We're exploring 4D printing and additive manufacturing. So while 3D printing gave us the power to build complex shapes, 4D printing adds the dimension of time, meaning objects that change shape after they're printed. The sources point to a ridiculously advanced manufacturing technique utilizing a material called a vitromer. Now, a vitromer is a special class of plastic that sort of bridges the gap between different polymer types. Using a process called UV cross-linking, scientists can perform rapid volumetric additive manufacturing while the material is in a solid state. Okay, in simpler terms, instead of melting plastic layer by tedious layer, they can use light to rapidly cure and program massive solid blocks of these hydrogels and vitromers in 3 dimensions all at once. It is a massive leap forward in how we fabricate complex, shape-shifting objects. And what does this hyper-advanced manufacturing actually allow us to build? Well, it enables incredible engineering feats based on controlled folding and unfolding. The sources mention something called active disassembly. Imagine if complex electronics or machines could be triggered to simply dismantle themselves for easy recycling the moment they reach the end of their lifespan. Even more impressive, the aerospace industry is looking at morphing wings. These are airplane wings made of shape memory composites that smoothly change their aerodynamic profile mid-flight without any heavy, clunky hydraulic flaps, just by changing their shape. It's a total paradigm shift. Which leaves us with a pretty thrilling thought to end this explainer. We started this journey with natural biopolymers from billions of years ago, and we are now engineering morphing airplane wings and self-tightening surgical staples. So, as these smart materials continue to mature, how soon will our everyday world actively adapt, assemble, and disassemble itself purely on command? The illusion of shape memory has basically become the blueprint for our future. Thank you so much for joining me on this deep dive into shape memory materials. Keep your eyes peeled, folks. The objects around you might just start shape-shifting a lot sooner than you think.